Okay, Science 10, so now we are going to go over velocity. Now, we went over speed the other day, which is distance over time. So you might be asking, what is the difference between speed and velocity? Well, here's an example. If you have a car going to the right, its speed is 25 meters per second. That's all you have to say. But its velocity is positive 25 meters. What do you think that positive is there for? Well, to have another hint, if it's actually going to the left here, its speed is still just 25 meters per second, but its velocity is negative 25 meters per second. So what do you think that positive and negative is telling you? It's telling you the direction, and that is the difference between speed and velocity. Velocity is all about the direction it's going plus how fast it's going. Okay, and so that's what we call a vector. So a scalar is something like speed. It just consists of the magnitude. The magnitude is just how much. So for example, when you see a sign that says the speed limit is 60 kilometers per hour, well, it's not telling you what direction that you have to be traveling 60 kilometers per hour in. So that's just a scalar. That is just telling you the speed that you have to go, right? It's not telling you your velocity because it's not saying what direction you have to be going. Okay, another weird example of a scalar is time of day, or at least as we see it on a clock like this. We're going to watch because we have to infer by, what it's like outside if it's AM or PM. Right? So it kind of doesn't give us that direction or all the information if we're just looking at it like that. So a vector is something that consists of magnitude and direction. So again, magnitude just being how much, how big. Okay? So something like this, when you see this kind of sign, this is a vector. This is giving you the direction. It's actually not giving you the magnitude, like how far away something is, but say you see a sign that says, Airdrie 70 kilometers or something like that, north. So that is a vector because it's giving you magnitude, how far away it is, and the direction that it's in. Okay, so that's a really important part about vectors. So before we get on to velocity, or a little bit more about velocity, we need to talk about displacement. So displacement is kind of the vector version of distance, although it's not quite that easy. So say you are going to take a walk because, you just are getting sick of being holed up in your house. And so you're going to go for a walk. So here's where you start. And then you go along here and you go all around. And you're taking a nice little walk around. Okay, and then you go all the way around here, and then you end here because, I don't know, there's a nice bench or something, and you just want to sit on it for a little bit before going back home. So what distance did you go? Well, your distance is how far you walked all around here, because obviously that was a nice long walk and not a direct route to exactly where it is. So that's what your distance is. Your displacement is the direct distance. So the shortest distance from your starting point to your ending point. Okay, and that is what displacement is. So what is the shortest distance from the starting point to the ending point? Okay, so distance doesn't require a direction because also you can just kind of mosey around. But displacement is the direct distance from the starting to ending point, and then of course also needs the direction that you've headed in, or the direction of your displacement. Okay, so that's going to be really, really, really important to look at displacement like that. So it's not only just that your distance with a negative or positive on it, or a direction on it. If you take a nice roundabout way of going somewhere, which is pretty much the whole point of like taking a nice walk, then that's not going to be the same number as your displacement. Okay? So let's just do a few examples. So say your mother is driving you 20 kilometers from your house to a friend's house. Oh, weren't those the days? So now we'll just say that you're driving to a friend's house to, I don't know, drop off some baking or something. But obviously just waving to them from the lawn while they're on, like, they're at their front door, and yelling at them at their front door. So let's just say you're doing that for now, okay? So here we have a house. Here's your house, okay? Cute little house. Okay. So your mom's driving you from your house to your friend's house, 20 kilometers away. What a good mom. My goodness. All right. So what's going on? So your mom's going 20 kilometers this way. Okay. And then dropping you off there, and then going back home. And of course, how far does she go back home? She goes 20 kilometers. Okay, so first question, how far did your mom travel? That is asking you the distance. How far did she travel? She went 20 kilometers there, 20 kilometers back. So how far she traveled is the distance. And that's 20 kilometers plus 20 kilometers, right? Which is a total of 40 kilometers. But then it asks, what was her displacement? Well, again, displacement is how far you are from your starting point. So if your mom started at your house and ended at your house, what was the displacement? It's 0. Her displacement is 0. And that's just the sad fact. So sometimes distance is a better measure than displacement. But there we go. Displacement is 0 kilometers because she started ended where she started. Right? So such is life. That's that. All right, let's do one more example here. Usha and Melissa traveled from Cathy Creek Crossing south to Nick Brook Crossing. Okay, so I'm gonna draw this out. I always like drawing this out. So here's Cathy Creek Crossing. I'm gonna call that Cathy Creek. Okay, and you're going south to Nick Brook Crossing. And that is 30 kilometers and takes 2.25 hours. And then you're going to head north to Michael Creek Crossing. Okay, so then you're here, but I'm just going to move you over a little bit. And you're going to go north, and you're going to go north 45 kilometers. Okay, and then of course this is Michael Creek Crossing. And this is 45 kilometers. Okay, so we want their distance and their displacement. Okay, so distance is easy. So like how many total kilometers did they travel? Well, they went 30 kilometers south and then 40 kilometers north. But again, we don't care about those directions. They drove 30 kilometers and they drove 45 kilometers. So we just add those together. So in total, that should get us 75 kilometers. Beautiful. So therefore, their distance is 75 kilometers. Now we want to know about displacement. Okay, so now if we're talking about displacement, what happens? They go 30 kilometers south and then 45 kilometers north. So I just want to know how far away they are from their starting position. So if I'm looking at displacement, I'm just looking at what is this distance right here? Because here's the starting position, here's the ending position, okay? So I want to know what's the difference there. What is the displacement? And how far are they from their starting position? Okay, well, a lot of you can already see, well, this is probably going to be 15 kilometers here, right? Because that's 45 is 15 kilometers north of that 30 kilometers. Okay, another way of writing it is, since this 30 kilometers is south, I'm actually going to put a negative there. So we're going to start to use negatives and positives to denote direction, and I'll be going over that a little bit more very soon. But I'm going to put the negative there for 30 kilometers, saying that that is south. So that's actually how we say something is going south. We put a negative in front of it. And then I'm going to add to it 45 kilometers, and I'm going to keep that 45 positive because it's going north, and north we usually say is the positive direction. Okay, so negative 30 plus 45 is 15 kilometers. Okay, and there we go. That is our displacement, meaning that is how far the ending point is from the starting point. Okay? So this now brings us into velocity. You really, really, really need to know what displacement means and how it's different from distance, because that is going to make the difference between speed and velocity as well. So velocity isn't just like speed, but with direction. There is a slightly different definition of velocity. So remember, speed was distance over time. Velocity is displacement over time. Okay, so a few weird things here. Maybe you're noticing these weird little arrows on top. That means that it is a vector. So when you see that arrow on top of something, that's telling you that it's a vector. Okay, because here's the annoying thing, is the equation for speed looks like this. It looks like exactly the same. Right? What's the only difference? It doesn't have these little arrows on top. And so that's the only way that you know the difference between velocity and speed, okay? So V without an arrow over it is just speed. V with an arrow over it is velocity. D without an arrow over it is distance. And D with an arrow over it is displacement. Okay, so where speed is distance over time, velocity is displacement over time. And we just saw in the last two examples, displacement can be much different than distance. So before we get into some examples of that, of how to calculate velocity, let's go over the sign conventions, because these are really, really important. So for Science 10 physics unit, I just want you to think, okay, we have positive directions and we have negative directions, and they always stay the same. So your positive directions are going to be northeast, up, and forward. Your negative directions are going to be south, west, down, and backwards. Okay? So if we want to write an expression for these guys, so I traveled 25.0 meters west. Again, west was what? It was negative. Okay, so that will have to be negative. The rocket went 2,500 meters up. What is up? Up is positive, so that one will have to be positive. So when we write them, the 25 meters west will be like this, right? Because we have that negative in front saying that it's west. And then what we do is in these square brackets, we put the direction it's going. So for west, we can just put W, okay? So we'll just, for west, in the square brackets, we'll just put W, okay? And we can do that for all those navigational ones. So east, we'll just do the square brackets and you put an E in there. For south, you do the square brackets, so you put an S. For north, you do the square brackets and you put an N in there. Okay? For up, you just put up in the square brackets, or down in the square brackets, or forwards or backwards in the square brackets as well. So you can also do that. Okay, so that's how we're going to write that. Now the 2,500 meters per second rocket going up, since up is the positive, we don't need to actually put anything in front. You can put a positive if you want to, but you don't have to. If there's nothing there, we just assume that it's positive. And then if there's a negative there, then of course it's negative. Okay? And that's really important. I know it's finicky, but it really helps you keep track of things and helps you calculate displacement when you have some negative and positive directions going together. Okay, so here's what I said before. Now, just because I want to make sure we're all on the same page, just so you know, when you're on the page, the top of your page is north, the bottom of your page is south, the right of your page is east, and the left of your page is west, okay? So the positives are here with north and east, so that's positive, which makes total sense, because if you are working in math, for example, this is the positive x-axis going east and the positive y-axis going north, right? So we haven't changed anything there. And then, of course, west is negative and so is south. Those are both negative, okay? But if something's going up, like off the ground, that's going to be positive. It's going down, then like into the ground, then it's negative. And then forwards, we are going to say we're going positive direction, or something's backing up, like a car backing up out of a driveway, that thing is going negative, okay? So here is kind of your up, down, left, right, or if you want to use the navigational coordinates, north, south, east, west, that's how it's set up. So make sure that you kind of know what's going on. And usually, like, if it says that a ball is being thrown up, you know that's going up. And then you know you're going to use this method, right? If it says that somebody is traveling north, then you know you're going to be using the navigator coordinates. Okay? And that's how that is working. So let's go over a few examples. So we have a group of students walking 10 meters east, that's what that means there, in 7 seconds. So we've been given displacement and time there. And then they walk another 12 meters east in 8 seconds. So we want to know their displacement after 15 seconds. So it makes you think that you need to do something with the seconds here and do something with the time here. But if you think about it, 8 plus 7 seconds is 15 seconds. So they're walking that total distance in 15 seconds. Okay, so let's take a look at this. We want displacement, so we just draw the D, but we draw the little arrow thingy over it to know that it's displacement and not distance. So they're going east, so therefore that is a positive 10, because again, east is positive direction, and then you just add. And then we're going 12 meters east. Oh, so that's another positive direction, so we just add those together. Okay, so what do we get? What's their displacement? It's just 10 plus 12. Isn't that nice and easy? So that is 22.0 meters. Always remember your significant digits. This has 3, the 10.0 has 3, the 12.0 has 3. So my answer should have 3 significant digits, which it does. So there we go. There's our displacement. It is just 22.0 meters. Okay, next one. What is the average velocity? What is their displacement over time? So remember, we know velocity, that's the V with the arrow over it, is equal to the displacement over time. Their displacement, we just found out, is 22.0 meters. And we divide that by how much time it took, which is 15.0 seconds. And that's all we have to do. Okay, so if I divide those, I get 1.46 continuing. Okay, and that's meters per second. This, if you put that continuum over there, it looks like it's 3 significant digits, but it's not. So remember, 1.46 continuing is 1.46666, so on and so forth. So if I want to round that to 3 significant digits, okay, well, I have, where are my significant digits? You start from the beginning and you go back. So we've got 1 there, 2 there, 3 there. So we got to stop at the 6. But again, what comes after the 6? Another 6. So I have to round this guy up to 7. Okay, so that is actually 1.47 meters per second. Okay, and there we go. There is their velocity. Oh, whoops. I forgot something in my answer. How dare I? Okay, you guys. You're allowed to criticize me now. I can't believe I forgot that. This is not done. What did I forget? What did I not put? I didn't put the direction. These are supposed to be vectors. They need directions, not just magnitude. That's all I'm writing down right now. What is their direction? Well, this was east and east, so this is obviously east. Their direction again was east and east, so therefore their velocity is also east. There we go. That looks much better. And of course we keep them as positive because, well, they're going east. East is always positive. Okay? Awesome. Let's do one more and not forget the directions now. Okay, so we have a boat traveling at a velocity of 8 meters per second north for 14 seconds. What is the displacement? Okay, this one's a little bit different. This is one where they gave us the velocity. Okay, so our velocity is what? 8.00 meters per second. That is 3 significant digits. Please keep that in mind. They gave us the time, which was 14.0 seconds, also 3 significant digits. And what do we want? We want the displacement. So if we write out the equation we have for velocity, displacement, and time, that is velocity equals displacement divided by time. This is not set up to solve for displacement, is it? Nope, it's not. Therefore, I need to rearrange, don't I? I need to get displacement all by its dang self. Okay? So, again, look at displacement. It's this guy right here. What are we doing to that thing right now? We are dividing it by t. I need to do the opposite. What's the opposite of dividing? It is definitely multiplying. So what am I going to do? I'm going to multiply this side by t. This whole thing, I'm going to take it, multiply it by t, so then those can cancel out. Anything I do to one side of the equal sign, I got to do the other. There we go. So we are left with displacement, all by its lonesome, aren't we? Which is good. That's what we want. So displacement is here over by itself, and then here we have time times velocity. Okay, now I'm just going to rewrite it this way because it's nicer. Okay, TV, look at that. What we're not watching right now, right? Well, we learn physics, of course. Good. All right, so we just take time and multiply by velocity. That'll be nice. So 14.0 seconds times my velocity, which was 8.00 meters per second. By the way, when you are doing something that you have to hand in, you do have to show all these steps where you are plugging in the numbers. Okay. All right. So let's find our answer. 8 times 14. That is 112. So before we write anything else down, so first of all, we know that is going to be meters now, right? Because that's the thing for displacement. So a few things to remember. Significant digits. Do we have the correct amount? This had 3. This had 3. This guy has 3. Perfect. So we have 3 significant digits. What else do we need to do to completely finish? They asked for displacement. Displacement is the magnitude of something plus its direction. So since the velocity was north, guess what? The displacement is also north. That makes a lot of sense, because if you have a velocity going north, it would be really, really weird if you ended up going south, if you ask me. Okay, so there we go. There is our final answer for the displacement of the boat. One more example. Because honestly, you guys, this is what this takes. It's just doing example after example after example. If you do a ton of examples on this stuff, you will get it down. Okay? A lot of people are like, I don't love math. I don't like math. And I think the reason is because you just have to do it over and over and over. And it can get kind of tedious. But honestly, if you're complaining that you're not very good, you just got to do more to get better. You have to. Okay? So let's do one more example. Car moves 200 kilometers south. Okay, so we know that we should probably make that guy negative because it's going south, and south is one of our negative directions. Remember, sometimes you got to draw your little navigational thing up at the top of the page. I would recommend doing that. North, south, east, west. Okay, so south is negative. In 2 hours... rests for 1 hour, so that means it's going 0 kilometers per hour, and then returns 100 kilometers north. Okay, and that's positive, and that happens in 1 hour. So we want the car's average velocity over the whole trip. So if we're looking at average velocity, we're looking at its entire displacement over the entire time it takes for the whole trip. Okay, so again, average velocity is total displacement over total time. Okay, so let's think about that. First of all, what is its displacement? Well, it starts by going 200 kilometers south, so that is negative 200 kilometers, right? And then it's going 100 kilometers north, so that is plus positive 100 kilometers. Okay, so there's its total displacement. And then the time, well, we have 2 hours here that it takes to go the 200 kilometers north. Then we have the 1 hour of resting, and then we have the 1 hour going north, okay? And that's how we're going to do that. So what's negative 200 plus 100? That is negative 100, okay? And then we have 2 plus 1, which is, oopsie, 4.0 seconds, wow, hours. Okay, so our final answer then is negative 100 divided by 4 is negative 25. Okay, let's double check that we have the correct number of significant digits. The 200 and 100 have 3 significant digits. However, the 2 and the 1 and the 1 have 2 significant digits. And I know we're doing like a combination of adding and subtracting and dividing. So just go with the dividing rules after that, okay? Because that's the last thing that we do. So I'm going to go with 2 significant digits, which were here. I know here my units are kilometers per hour, not meters per second, because I was using kilometers and hours. What does that negative mean? That negative means it went what direction? South, okay? We're just dealing with south and north. At this point, we're not gonna do stuff where they're going like east and then north, okay? Because then you need a combination of those two. So we're only working in one direction, okay? Either north-south or east-west. Okay, so there we go. There is their average velocity. And then if I want the car's average speed, well, the average speed, then we don't have any vectors. We don't have to worry about displacement. It's just the total distance over the total amount of time. Okay, so what's its total distance? I don't care about directions. So I know it goes 200 kilometers and then it goes 100 kilometers. Okay, there we go. What's the total time it took? Again, it was 2.0 hours plus 1.0 hours plus 1.0 hours. Yes, you can just put 4 hours there if you already just want to add them together. Okay, so what is that? That's 300 kilometers divided by 4 hours. Again, I do need 2 significant digits here. So when we do 300 divided by 4, that actually gets us 75. Yay, that is 2 significant digits. And that is kilometers per hour. And I do not need to worry about putting a direction on there, a negative or anything. So there we go. See, so velocity and speed can be very different because displacement and distance are very different. So that's going to be tricky for you. Once you do mix in velocity questions with speed questions, you got to remember distance versus displacement. Okay, so anytime you see velocity, you're like, oh, right, average velocity means displacement. And then anytime you see speed, you got to know, oh, that's working with distance. Okay, so please keep that in mind. Good luck on your practice questions. We're getting to the point where it is so important that you do those. Okay? Good luck, and I will talk to you. You'll be hearing from me next lesson.